Hello everyone, welcome to the platform for Unacademy, India's largest online learning platform. So I welcome you all to this platform in which we have started our journey of manufacturing series for your preparations of GATE and ईएसई. And we have been started the most important and most peculiar topic, which is somewhat maybe some of the students are skipping these topics. We have started the topic of non-traditional machining process. So let's start our discussions, and in these discussions we are going to see some of the new topics. So before proceeding, let me give a brief introduction about myself. My name is Vidyapati Kumar and I have a 4+ year of teaching as well as research and development experience. I have done ME from Jadavpur University. I have worked at CSIR, Central Institute of Mining and Fuel Research, qualified GATE twice, and I'm the author and co-author of various research papers publication of national and international journal of repute. You can follow me here at unacademy.com at the rate of v.kesar, where I have completed almost everything about the strength of material, and the last chapter is going on. You can follow me here, and I will be uploading the new courses and scheduling the new courses. New videos will be there, and you will be getting notified at the same time. So in this session, we are going to see the ultrasonic machining and the chemical machining. Basically, I have introduced these machining processes in my introductory lectures of non-traditional machining process. And in this particular session, we are going to see the principles of ultrasonic machines, how basically we are using the ultrasonic vibrations for the machining purposes, as well as how we are using the chemicals for the machining purposes and getting the desired product with the required shape features. But before that, if you have not downloaded the Unacademy Learning app, download the Unacademy Learning app and you can watch the free special class of mine in which I'm teaching the strength of material. That is totally full courses there, and basically it is for GATE 2021. So definitely you can go and watch those free lectures. So basically daily live classes are there, so you can interact with not me but all the educators which are present on the Unacademy app. So definitely you can watch and uh, interact with them and get your doubts clear at the same times. In the plus subscription, if you have not taken the plus subscription, then take it because it is totally worth it. It is totally worth it. Entire syllabus is covered. By taking the plus subscription, you are enrolling for the GATE as well as the ईएसई. So in both the purposes, you are getting the plus subscription. So there would be a daily live classes. Courses are very much structured in nature. That is totally in a chronological order. It is arranged, as well as tests and quizzes. You will be given an unlimited access of all the content material. So either it is free or the paid. So each and every material would be access to you. Apart from that, doubt clearing sessions would also be there. So there are a lot of benefits, as well as if you are trying to go for the iconic subscription, these are the benefits. So you will be getting the benefits of the plus, as well as these extra benefit that you are getting. Personal coach. You can choose any of your educator to be your personal coach that is liable to help you throughout the preparation of GATE and ईएसई. So basically you are getting these benefits in the plus subscription, and you are getting in the iconic subscription plus benefit something extra benefit that you are getting, that is the personal coach will also give you the personalized test analysis, as well as that will give you the study planner, what should be studied, how should be studied, and these things would be given to you. And preparatory study materials like PDFs and the other content materials would be given to you for your perusal. You can also learn with the India's top educators by enrolling in any of the courses, as well as for the GATE and ईएसई there are a lot of batches which has already been started in the month of October and November for each and every branches like mechanical, civil, electrical, electronics, production, industrial, and so on and so forth. So definitely you can go and watch these search about these batches if you really want to enroll in that. Some of these batches are rank improvement batches, rank booster batches, target ESE prelims batches for mechanical, civil, for the gate preparation 90 days, for the ESE prelims like rapid revision batches are there, doubt clearing batches are there, right? So there are a lot of batches, rank improvement batches are there. So there are a lot of batches which has already been started. Definitely you can go and check out these batches. Apart from that, if you want to enroll in the plus subscription, so definitely you can enroll with my code SIRVK, SIRVK, to get the 10% off in all the prices. What I mean to say from it, for example, if you are enrolling for the 12 months, it will be costing around 30,250. But if you will using my code SIRVK, then you will be getting a 10% off, as well as you will be getting my personal mentorship program. So discounted amount would be 27,225. So those who are doing the preparation for GATE 2021, so definitely they can go for these plans, and those who are in second or a third year, so definitely they can go for these plans. But do not forget to use my code SIRVK to get a 10% off, and you will be getting my personalized mentorship as well. If you are planning to go for the iconic subscription, again use my code SIRVK, SIRVK, to get a 10% off, and the discounted amount would be like that. Good evening, Ashish ji. Good evening, Subham Raj ji. Okay. So those who have told me that lecture number 30 is not available, so I have checked with the team, I have talked with them, and definitely there is some discrepancy. So they will be adding, I have already let them know about these problems, and they will be adding this lecture number 30 in that playlist, within some days. Fine. But for those who have not able to find it, so definitely you can search by these keywords in the YouTube, and you will be getting the results. Either this is the link that is available for lecture number 30. So let's start our discussions again. Once again, this is the link that many of you have told in my yesterday's lecture, that lecture number 30 is missing. So this is what is from my side. Within 4 to 5 days, they are going to update the playlist. Okay. See here. So in my introductory lecture, I have started and told you that there are the mechanical energies. Okay. So there are some kind of machining process, such as the ultrasonic machining, abrasive jet machining, water jet machining. So basically in these machining processes, we are using the mechanical energy. And by means of mechanical energy, the shear and erosion takes place. Shear and erosion on the workpiece takes place, and by the mechanism of shear and erosion, the material is removed, and hence the machining is done. What are the sources? Basically, the shear and the erosion is taken place by the help of the fluid or by the help of the particles. What I mean from this particle, that is abrasive. And either using the fluid or using the particles, or you can use the fluid or the particles. What I mean from the particles is that abrasive particles. So either combination would lead to the shear and erosion on the workpiece. So basically if this is your workpiece, and suppose this is the fluid, so basically if you are giving a very high jet, a very high pressure fluid, then you will be getting a water jet machining. If you are giving abrasives like this, so when the abrasives are striking on the workpiece, then they are giving the kinetic energy, and what they will be doing, they are actually indenting they are actually producing the indentation on the workpiece, and hence the material removal rate takes place. So let's talk about our ultrasonic machining in this particular session, and let's try to analyze what is happening in this particular machining process. Subhamraj, after this NTM process will be finished, NTM process will be finished. After this NTM process, I will take some of the machine tools part, and after the machine tools part, I will start the metrology. Okay, because metrology is less important if you are comparing with the NTM and the machine tools. Okay, so I am teaching you on the basis of the marks that has been asked in the gate based upon the priority. Now try to understand that what is happening in case of a ultrasonic machining process. So what is happening in ultrasonic machining process? See here, suppose you have a workpiece. So this is your workpiece. Now on this workpiece, what you are giving, you have a tool. So suppose this is the tool, suppose this is your tool. Clear? Now what you are doing, just try to understand this. What is the problem? SVNIT mechanical engineering, what do you want to tell? Okay, see here, basically suppose that this is your tool, and this is your workpiece. Now what you are doing, you have an abrasive slurry arrangement. Suppose this is a nozzle, suppose there is a nozzle, and with this nozzle, what you are doing, this nozzle is basically connected with the abrasive slurry particles. What is the meaning of abrasive slurry? What is the meaning of abrasive slurry? Basically this is known as abrasive slurry. See here, we have some kind of abrasive particles. Okay, so some kind of abrasive particles such as boron carbide, such as aluminum oxide, such as diamond dust. Okay, so these are the abrasive particles. So what is the meaning of abrasive? अगर आपको मैं बोलूं कि पत्थर को उठाएं आप, if you are taking any kind of a stone, so you would see a sharp edges would be there on that stone, and that is the basic thing of the basic property of the abrasive. So abrasive is a type of material in which the sharp edges would be there, and that is used for the mechanical erosions in this case. Clear? So what is here, so basically the abrasive particles are there like that, as well as these abrasive particles are mixed in the water. Okay, so basically suppose that if you have a abrasive particles like Al2O3 aluminum oxide, and you have mixed this in the water, so basically this is known as the abrasive slurry. Now what you are doing, try to understand this tool. In this tool, basically on this tool, what you are doing, you are applying some kind of feed force. Okay, you are applying some kind of feed force, and you are giving here the vibration, you are giving the vibration frequency. Basically, this is your tool and you are giving this tool a vibration frequency. What I mean from this vibration frequency is that this tool will be vibrating like this. This tool will be vibrating like this. Now, how vibration frequency is produced? What is the significance? Don't get into that thing. I will clear each and every doubt just after some time, but stick with me and try to absorb what I want to give you at this time. Okay, now see here, we are giving the feed force, and the feed force in this, the vibration frequency is given to the tool. So tool is moving like that, tool is moving like that. Now what you are doing, you are supplying the abrasive particles from here. Clear? So you are supplying the abrasive particles from here, and this tool is moving like that. This tool is moving like that in the upward and downward direction, and you are supplying the abrasive particles from this nozzle. And again, what is happening, due to this, the erosion will be taking, due to this, the erosion will be taking place on the workpiece. And again, after the erosion, this entire abrasive slurry will be moved out, and it will again go back to this abrasive slurry tank. And in this abrasive slurry tank, again it is with the help of the pump arrangement, it is again fed to this part. And this is how basically the machining is taking place. So here at this point, vibration frequency is created. So basically the frequency that is created, which is in the range of 20 kilohertz to 30 kilohertz. Now see here, with some kind of arrangement, the vibration frequency is produced. I will let you know what are the arrangement are there. So basically this is the frequency, and this frequency is not actually listened, or we cannot hear this kind of frequency with our ear, and hence this is known as ultrasonic frequency. And hence the machining which is taking place in this process is due to this ultrasonic frequency, hence it is known as ultrasonic machining process. Clear? Sir, abrasive slurry का कोई general example? Yes, I have told you, Asis. That basically we are taking a lot of abrasive slurries like Al2O3, like aluminum oxide, like boron carbide. A lot of things are there, I will let you know. Okay, diamond dust भी हम use करते हैं, है ना? But this is diamond dust is very costly. Okay, so definitely we are not going to use those things. But general things are aluminum oxide and boron carbide. Okay. Now try to understand. So basically this is the main working things. This is the main working things, right? Now let me draw the figure, exact figure, and then you will be understanding the basic principles behind it. Okay, now see it here. So here, suppose that this is your ultrasonic oscillator. This is your ultrasonic oscillator. What is ultrasonic oscillator? Basically, ultrasonic oscillator is a device in which frequencies are oscillating, and from here the frequency are given to the system. Okay, so from the ultrasonic oscillator, the frequencies are given, ultrasonic frequencies are imparted on the system of the ultrasonic machining. Okay, now try to understand the second part. This is known as transducer. This is known as transducer. Now what is a transducer? What is a transducer? So basically this ultrasonic oscillator is connected with this transducer like this. So there is a winding, there is a winding like that, there is a winding like that. Now try to understand that this ultrasonic oscillator is connected with this part that is known as transducer. This is known as transducer. Now just now I have told you that this tool is given the feed force, isn't it? This tool is given the feed force. Now how you are giving the feed force and how this tool is moving and oscillating in this direction like this? How? So basically the function of the transducer, is that from the ultrasonic oscillator, frequencies are given. Okay, so let me write it here. Frequency, whatever the frequencies are given by the ultrasonic oscillator, it is given to the transducer, and this transducer converts this electrical frequency into the mechanical vibration, and this is the most important working of the transducer. This is why we are using the transducer. Fine. Now basically in this case we are using the material of the transducer, which is made of the magnetostrictive. Just a minute, let me write it here. The material is made by magnetostrictive. So this is the material by which this transducer is made. This is the material by which the transducer is made. Now see here. Now I have told you that this is the frequency, isn't it? Now the amplitude actually in this case is very low, which is of the range of 0.01 mm to 0.1 mm. So basically in the ultrasonic machining, one thing that you have to keep in your mind, that frequency is higher. You can see here frequencies are higher, and amplitude of vibrations, right? So ये जो vibration कर रहा है ना, इसका जो amplitude होगा वो less होगा. Amplitude of vibrations will be less. This is the most important thing that you have to keep in your mind. ये दिख रहा है ना, amplitude of vibration बहुत ही कम है comparison to the vibration frequency. So basically what is happening in this case, you can understand that amplitude is very less. अभी सोचिए अगर आपका एम्पलीट्यूड बहुत ही कम है तो फिर आपका जो एनर्जी होगा ना वो भी तो बहुत कम प्रोड्यूस होगा ना. तो अभी आप अगर एनर्जी आपका कम प्रोड्यूस हो रहा है तो आप क्या कर सकते हैं, आप वेस्ट नहीं कर सकते एनर्जी को. एंड व्हाट यू विल डू, यू विल ट्राई टू कंसंट्रेट whatever the amount of energies are actually produced in this tool, you will want to concentrate at a certain point where you want to remove the material, isn't it? And for that purpose, and to concentrate the all amount of mechanical vibrations at a single place, the material, the shape is used that is known as tool horn. So that is somewhat like that. Now see here, what is this? Basically the mechanical vibration is taking place, isn't it? So अभी आप देखिए, अगर यहाँ पर आपने टूल को लगा दिए, अगर if you have put the tool here, if you have put the tool here, then what would be happening? The mechanical vibration would be distributing throughout this place. Mechanical vibration would be distributing. But if you want to do the machining, at this kind of place, at a very constricted zone, then you do not want the mechanical vibration to be lost in these entire zones, right? For that reason, a concentrator is used, that is known as tool horn. Okay, So I hope you understood the use and utility of the tool horn. Okay, now see here, let me write it here. This is your tool horn. So basically this is your tool horn. And on this tool horn, you are either welding a tool or brazing. So basically here at this point you are welding or brazing. Okay, basically at this point you are either welding or brazing based upon the requirement the tool. Clear? So this is the tool horn and this is the tool, and you are welding these parts here. What is tool horn? Please ek bar or explain. Okay, see here, what is the use of the tool horn? Try to understand. I have told you that whatever the frequencies are generated from this ultrasonic oscillator, that is given to the transducer. Now the transducer is made of the magnetostrictive materials, and what is the utility of this magnetostrictive materials? With the help of the magnetic fields generated in this transducers, it is actually converting all the frequencies which has been given by the ultrasonic oscillator in terms of the mechanical vibrations. Okay, now try to think about it, that this is the end of the transducer, and now if you have connected this tool, here only, suppose if you have connected this tool here only, then what you can understand, entire mechanical vibration would be happening in this entire part, isn't it? Now try to understand, the mechanical vibration will be happening in the entire part, and this is what is your tool. So this much amount of the mechanical vibrations are actually wasted, and that is why what you are doing, you are actually concentrating this whatever the amount of mechanical vibrations produced at a certain point. Now if you are concentrating at a certain point, what will be happening? Because you want to machine at a certain place, isn't it? Now if you want to restrict your machining process to make a cavity, to make a holes, whatever the shape features you want to restrict them at a certain place. So that is why if you want to restrict at a certain place, then you have concentrated all the mechanical vibrations which is produced at a certain place, and by concentrating, machining will be happening at this particular place, and machining will be very high, because concentration करने के साथ एनर्जी वहां पर ज्यादा लोकेट होता है, एनर्जी वहां पर ज्यादा हो जाएगा, है ना? So I hope you understood. Now see here, these things are clear to you. Now this is the tool, clear? This is the tool. So this is the tool. Now here will be the workpiece. So basically whatever the shape of the tool will be there, the same shape will be replicated on the workpiece. Clear? So suppose that this is your workpiece. And on this workpiece, a abrasive slurry tank is there like this. In this, the abrasive slurry is filled with the help of the pump. This slurry is actually supplied here. There is a nozzle which is fixed. Now also one most important point that I should tell here, that in this abrasive particles are there, right? Abrasive particles are there, plus the water is there. Now what is happening due to this? The very abrasive particles will have a lot of edges, sharp edges, so it will destroy the nozzle. Hence nozzle is made of a very hard materials that is known as tungsten. Fine. So this material, this nozzle material is made up of the tungsten. Clear? So this is the nozzle, and from this nozzle, the abrasive slurries are coming like that. Fine. And the machining is done. Okay. Now you can also understand these things by the actions of this. Try to understand. This is your workpiece. This is your workpiece. So suppose this is your abrasive particle. So I have drawn in a very exaggerated manner. So what is happening due to this abrasive particles? Try to think. Due to this abrasive particles, this part of the workpiece will be getting into indentation. So there would be a indentation. The purpose of the tool horn is to concentrate the ultrasonic vibrations. Am I right? Yes, 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 Shivam Raj, yes. Now try to understand that this is your abrasive particles. This is your abrasive particle. Now this abrasive particle will give a indentation on the workpiece. Now the indentation, due to this indentation, this much amount of materials are removed. Okay. Now suppose there is another abrasive particles like that. Now due to this abrasive particles, this is the again this much amount of indentation which will be happening, and again this much amount of materials are removed. So this is how there is the shear takes place, and due to this shear, erosion of the materials are taking place. And hence what I have written in the very first slide when I was introducing these things, sir, I have told you that the mechanism is shear erosion. Why shear erosion? Because this is what is happening. हेलो मिहिर जी. हाँ, थोड़ा सा लेट तो हो गए हैं मिहिर जी आप. सर, इंडेंटेशन इज जस्ट लाइक द पेनिट्रेशन. डेफिनेटली आप इंडेंटेशन को कैसे फील कर सकते हैं? सपोज करें कोई एक सरफेस ले लें और एक पत्थर ले लें, और पत्थर में शार्प जो एजेस होगा ना, आप उससे एक मारे. जब आप मारिएगा तो क्या होगा? वो सरफेस पर एक इंडेंटेशन, मतलब कि उसके अंदर में कुछ पेनिट्रेशन, मतलब उसके अंदर कुछ गड्ढा हो जाएगा. And that is the same thing that is happening. Okay, so basic principles are actually taking place in this case. Okay, so this is what is happening, and I hope each and every points are clear to you. So let us give a brief notes to you so that you can have the proper understanding of whatever I have explained to you. So the first point that I want to write here, in this machining method, a slurry of small abrasive particles is forced against die work by means of a vibrating tool, removing the workpiece material in the form of small chips. चलिए, अच्छी बात है, सब कुछ क्लियर हो रहा है तो अच्छी बात है. नाउ इन दिस आई एम जस्ट गिविंग अ ब्रीफ थिंग्स, है ना. मैं आपको जस्ट ब्रीफिंग कर दे रहा हूं ताकि आपके पास एक नोट्स भी बन जाए आपका साथ ही साथ. ठीक है. Basically the abrasive particles that is given to here. So basically abrasive particles that are given here are, some of them are known as silicon carbide, aluminum oxide, boron carbide, or sometimes you can also use the diamond dust. But see here, my dear friend, this is very much costly, isn't it? This is very much costly. So it is not feasible, है ना? ये feasible नहीं है. So this is what you can understand. This is not mostly used, है ना? बहुत ही rarely used होता है. Suppose for the cases of the aircraft and the cryogenic purposes, this may be used. This may be used. Fine. Now see here, you can understand that the material in this case, the workpiece in this case is very much, sir, here how chips are forming, but in idiom. See, Assis, basically the things is that chips in the terms of this small particles, chips in the terms of this small particles like that, है ना? यहाँ से जो material आपका remove हुआ, that will be something like that, है ना? सपोज करें, आप एक चीज सपोज कर लें कि आप एक पत्थर से लेकर के किसी सरफेस को अगर मारते हैं तो छोटा सा टुकड़ा जो निकलेगा ना, वो इतना भी छोटा नहीं होता है कि आप उसको पाउडर बोल सकें, और वो इतना भी बड़ा नहीं होता है कि आप उसको चिप्स बोल सकें. तो बेसिकली हम उसको चिप्स के कैटेगरी में डालते हैं. ठीक है, इंटरमीडिएट साइज का होता है. ठीक है, आई होप यू आर गेटिंग द थिंग्स. नाउ द प्रोसेस, this process is suitable only for hard and brittle materials like carbides, glass, or better to say as ceramics. I have discussed in my yesterday's class that for the machining of ceramics we are using the USM. Why we are using the USM? Because इसमें कोई झंझट ही नहीं है ना. Electrical conductive materials हो नहीं हो मेरे को कोई फर्क नहीं पड़ता. Why? Because the mechanism of material removal in this case is shear and erosion, isn't it? So you are using for the carbides, glass, ceramics, silicon, and some precious stones. And for some precious stones such as germanium, or you can also go for the titanium and tungsten. ठीक है, या टूल स्टील्स में आप चले जाएं, टूल स्टील्स में भी आप मशीनिंग कर सकते हैं, या फिर आप डाई स्टील्स में मशीनिंग कर सकते हैं. एक चीज जो बहुत ही बड़ा इंपॉर्टेंट है वो आपने नोट किया होगा इन सभी मटेरियल्स में, दैट इज दीज ऑल मटेरियल्स आर हार्ड. These all materials are hard and brittle. ठीक है, हार्ड एंड ब्रिटल होता है. तो हार्ड एंड ब्रिटल जब होता है ना, तो होता क्या है कि actually you are giving, see, try to understand that you are giving the vibrating frequency. So vibrating frequency used for die tool is about, I have explained it, that it is about 20,000 oscillations per second. मतलब क्या हुआ, ये जो है ना, ये जो आपका दिख रहा है, this is, let me take the pointer. This is actually means like the oscillation produces 20,000 oscillations per second. Clear? So in this case, vibrating frequencies are actually giving the 20,000 oscillations per second, and due to this, here the frequencies that is generated, that is of the order this, that is 20 kilohertz to 30 kilohertz. And by using this frequency, you are doing the machining process. ठीक है? So fine, I hope these things are clear to you. And one more thing that I want to let you know, that the transducer is made of a magnetostrictive just a minute strictive material which is excited by the flowing high frequency. Now from where you are giving the high frequency? Basically you are giving the high frequency from the ultrasonic oscillator. What I have told to you, that vibrating frequency used for the dye tool is about 20,000 oscillations per second. So basically 20,000 oscillations per second is produced by this ultrasonic oscillator, and this 20,000 oscillations per second is actually transmitted or given to the transducer, and this transducer is made of the magnetostrictive material which is excited by giving the 20,000 oscillations per second to this transducer which is made of this material. तो इस material का खासियत यह है कि this material will be excited by the flowing high frequency, and by the flowing high frequency electric current, and this results in the generation of mechanical vibrations. Fine. And after that mechanical vibration is produced. Now think about it. Here the mechanical vibration is produced. Now you are using the tool horn, isn't it? So basically what you are using, so these vibrations are then transmitted to the cutting tool by tool horn or a concentrator. Fine, a concentrator. And due to this, what is happening? This makes the tool vibrate in a longitudinal direction. And this is what is the direction that I have shown to you, isn't it? This is what is the direction I have shown to you, that this is moving in this direction, isn't it? This is moving in this direction, in the longitudinal direction. Each and every point is clear to you or not? Just let me know. Now I'm just waiting for your reply, that whatever the points, whatever the salient features and the things that I have explained to you at this point of time, each and everything is clear to you or not? Just let me know. This is what I have to give you the information about the ultrasonic machining. That's it. Nothing else. Okay. So everything is clear, then that is very good. Now let us see about the advantages and the disadvantages. Okay. Let us see about some of the advantages and the disadvantages. Yes sir, except the function of the transducer. Function of the transducer is that, आशीष जी, ट्रांसड्यूसर का फंक्शन क्या है ये तो मैंने आपको बताया। यहाँ पर देखिए, ट्रांसड्यूसर जो होता है ना, ट्रांसड्यूसर बना होता है मैग्नेटोस्ट्रिक्टिव मटेरियल से। अभी ये जो मटेरियल होता है इसका एक खासियत होता है। इसका खासियत क्या होता है कि जब भी आप इसको, इस तरह के मटेरियल को वेरी हाई ऑसिलेशन फ्रीक्वेंसीज, मतलब वेरी हाई ऑसिलेशन का मतलब 20,000 ऑसिलेशंस पर सेकेंड आप अगर देते हैं तो क्या होगा, this material will get excited by the flowing of high frequency electric current. Now what is happen, when this material will be get excited, this material will vibrate, this material will vibrate. Okay, so when you are giving this, then what is happening, this transducer will start vibrating up and down in the longitudinal direction. Now what you have done, you have connected this thing, this transducer, with the tool horn to concentrate all the mechanical vibrations at a single point, like this, isn't it? Now by doing this, what is happening, now your machining is taking place at a concentrated place with very good efficiency. Okay, sir, is this theory asked in gate or only numericals? Mihir ji, from the ultrasonic, as far as the ultrasonic machine is concerned, only the theories are asked, not numericals are asked. Okay, numericals नहीं पूछे जाएंगे, बट हाँ इससे जो थ्योरीज बनते हैं वो जरूर पूछे जाएंगे इन टर्म्स ऑफ ग्राफ्स, है ना। मैं आपको सब कुछ बताता हूँ, डोंट वरी, आई एम कवरिंग ईच एंड एवरीथिंग, ठीक है। मैं इतना अच्छे से सब कुछ कवर कर दूंगा कि आपको किसी भी चीज की तकलीफ नहीं होगी, ठीक है। नाउ ट्राई टू अंडरस्टैंड अबाउट द एडवांटेजेस. What is the advantages? So one of the basic and most advantage in this case is that extremely hard and brittle materials can be machined easily. Because in case of the ECM and the EDM, so definitely we want to most of the means like अगर हमारा material conductive है, if my material is conductive, then no doubt we are going into the EDM and the ECM. But what if my material is not conductive? My workpiece is like that. This is the workpiece. If I want to make a means like workpiece, if my workpiece is like carbide, like glass, like the ceramics, like the plastics, what you will do? So for these kind of things, extremely hard and brittle materials which are also non-conductive in nature, you can machine by using this process. Okay, now see here, since there is no interaction between the tool and the workpiece, है ना, कोई interactions तो नहीं है, तो यहां पर जो एक चीज होता है, the machined surface, the machined profiles, or the machined surface, the machined workpiece are free from stresses. Okay, since it is a ultrasonic vibration is there, so the machining process is noiseless. The machining process is noiseless. ठीक है, क्योंकि अल्ट्रासोनिक वाइब्रेशंस प्रोड्यूस होता है, अल्ट्रासोनिक वाइब्रेशंस you cannot hear with your ears, and hence this is noiseless in nature. Now one most important thing that I also want to let you know, that see here, अभी यहाँ पे देख, ये आपका टूल है, ये आपका वर्क पीस है. अभी you know that whatever the shapes and the shape feature of the tool will be there, the exact thing will be replicated on the workpiece, isn't it? So for that purpose, you want your tool to be ductile in nature. Okay, आप क्या समझते हैं, you want your tool to be in ductile in nature. Fine, so what is happening here in this case, understand here. So basically there will be a tool like that. So this is the tool. Try to understand that this is the tool. Fine, this is the tool. Now I'm just removing this part and writing here that this is your abrasive particle. सी वाई आई एम मेकिंग दिस टूल ऑफ द डक्टाइल इन नेचर, क्योंकि देखिए अगर मैं टूल में उस तरह का शेप फीचर बना पाऊंगा तभी तो वो चीज रेप्लीकेट होगा ना। तो क्या हो कि अगर मेरा डक्टाइल मटेरियल का टूल हो तो डक्टाइल मटेरियल में मैं प्रोफाइल अच्छे तरीके से बना सकता हूं, अगर बहुत ही हार्ड होगा तो उसमें मैं प्रोफाइल नहीं बना पाऊंगा। इस कारण से फॉर दिस रीजंस द टूल इज मेड ऑफ द डक्टाइल मटेरियल्स। Now, try to think one most important thing, that if my tool will be made of the ductile materials, then there might be a condition that this abrasive particles may strike to this tool. This abrasive particle may strike to this tool, and if this is striking to the tool, then what will be happening? What will happening? You can understand here that in this case, if this abrasive particle is striking on the tool, then this much amount of indentation would be happening. This much amount of indentation would be happening. So due to these problems, due to these conditions, tool wear takes place. Tool wear takes place. Okay, tool wear takes place. Sir, can the workpiece resonate in this? No, no. Workpiece is fixed. Workpiece is fixed. What you are doing, see here, this is your workpiece, this is your workpiece, this is your workpiece, and this is the, suppose this is the tool, so suppose this is the tool and this entire thing is the horn, tool horn, fine. So what you are doing, this is vibrating like this, this is vibrating like this, and you are moving this, your tool horn and everything is arrangement is moving in this fashion, and hence the cavity is formed. Now one more thing is that it is vibrating in the longitudinal direction like that, as well as simultaneously a abrasive slurry is flowing out, and the abrasive slurry is actually striking here and making the shear, and the erosions are taking place, and again abrasive slurry आएगा, shear erosion होगा, वहां पे थोड़ा सा chip बनेगा और वो chip फिर से wash away, chip will be again washed away and taken to the slurry tank, like this abrasive plus water slurry tank. Clear or not? Clear or not? Things are clear or not? Okay, so these are the some of the advantages. Fine. Now if you are talking about the disadvantage, if you are talking about the disadvantage, then basically in disadvantage is that tool wear is happening, है ना, tool wear जो आपका हो रहा है, tool wear is happening. Clear? Tool wear हो रहा है आपका. So in this what you can say here, tool wear is less. Let me write properly. Tool wear is high and material removal rate is low. Fine, these are the disadvantages. Where you can apply? What are the areas that in which you can apply this material? So basically you can apply in case of a tool and die making process, because देखिए टूल एंड डाई मेकिंग जो भी आपका मटेरियल्स होता है ना, these materials are hard and brittle, है ना। जो भी डाई का जो मटेरियल्स होता है, जो भी आप डाई बनाए या फिर टूल बनाए, तो टूल जनरली हार्ड होता है और ब्रिटल होता है, और इस तरह के टूल में आप कोई भी शेप फीचर्स अगर देना चाहते हैं, यू कैन गिव इट बाय द हेल्प ऑफ द अल्ट्रासोनिक मशीनिंग. सर, द एब्रेसिव्स कैन बी रीयूज्ड or are discarded since it contains the workpiece metals? No, I have clearly explained here, that after using these abrasive particles, this abrasive particles move like this, and it is again sent to the abrasive tank. Again it is sent to the abrasive tank, and here the filtration is taking place, and again it is with the help of the pump, it is given with this nozzle. Okay, with this nozzle. ठीक है. So next is that you can also machining of brittle materials, है ना, brittle and hard materials. क्लियर, यही सब आपका मोस्ट इंपॉर्टेंट पॉइंट्स है. और किन किन मटेरियल्स में आप इसको कर सकते हैं, किन किन मटेरियल्स में आप इसको यूज कर सकते हैं, इन केस ऑफ ए कार्बाइड, इन केस ऑफ ए ग्लास, इन केस ऑफ ए सेरामिक्स, इन केस ऑफ ए सिलिकॉन, इन केस ऑफ प्रीशियस स्टोन्स, इन केस ऑफ ए टूल स्टील्स, है ना, ये सब केसेस में आप इनको यूज कर सकते हैं. Now let's talk about the process parameters. Now let's talk about the process parameter. Okay. चलिए, कोई डाउट नहीं है, अच्छी बात है. अब हम जरा प्रोसेस पैरामीटर्स की बात करते हैं. मतलब क्या? See here, when you are doing the machining process, so there are a lot of process parameters, such as in this case, what you have seen, that in this case you have seen that in this case you have seen that you are using the abrasive, isn't it? Now if you are using the abrasive, suppose if you are using the abrasive of silicon carbide, or if you are using the abrasive of boron carbide, then what do you think? If you are using the two different abrasives, you will be getting the same result or the different result? What is your opinion? What is your opinion? What is your opinion? Just tell me. If you are using these two different abrasives, then you will be getting the same results or the different results? Tell me. Different and same results in terms of, see here, that what is the responses. See, basically when you are doing the machining, so basically the responses are what? Material removal rate, tool wear rate, surface roughness, है ना, these are the responses. And abrasive, so basically same results, different results, since hardness of abrasive changes. Very good, Mihir, very good. So see here, hardness, basically hardness of metals are changing, so definitely for this reason different abrasives will give me the different results. Now similarly, if you are using the abrasives, so if you are using the different size of abrasives, suppose you are using a different size of abrasives, such that if a small size of abrasive is there, a very intermediate size of abrasive is there, or a very big size of abrasive is there, then definitely by using a different size of abrasive will also give you the different response, isn't it? Are you convinced or not? So basically this is what is happening. Okay, now what is the next thing? So next thing is that you are giving the frequency. So you are giving the frequency. So frequency you are giving, isn't it? So basically the frequency you are giving. So if you are increasing the frequency, decreasing the frequency, then what will be the changes in the responses? So this is also your second process parameter. Next process parameter, you can think about the amplitude. So what I have told you in my earlier slide, that basically the vibration frequency is varying in the range of 20 kilohertz to 30 kilohertz, and amplitude is varying in the range of 0.01 mm to 0.1 mm. Definitely if you are varying the vibration frequency and if you are varying the amplitude, the different results you are going to get. So this is also one of the process parameters. Clear? This is also one of the process parameter. And see here, you are giving some kind of feed force. With the help of mechanical vibration. A feed force is continuously given on the tool in case of a ultrasonic machining. So basically what you can understand, that if so due to this you can understand that feed force feed force. So variation in the feed force will also give you the different results. So these are some of the process parameters from which the questions may be asked in the GATE and the ईएसई, and hence you have to study these process parameter with utmost priority, with the same priority that you are giving the each and every subjects, है ना, सेम प्रायोरिटी देना है. चलिए समझते हैं इन चीजों को. Let's try to understand these things. If you are trying to analyze, so in this case we are only going to analyze the material removal rate. ठीक है, क्योंकि क्वेश्चंस material removal rate में ही पूछे जाएंगे आपसे. Suppose that in this you are plotting the MRR, material removal rate, okay, and in this you are plotting the size of abrasives. Now think about it that a very small amount of abrasive size is there, then material removal rate will be low, isn't it? So if a small size of the abrasive would be there, material removal will be late. If you are increasing the size of the abrasive more like this, then material removal will be more like this, right? Like this. And if you are increasing the size very large like this, then also the material removal rate will vary something like this. But if you are giving the abrasive particle something like that, अगर आपका size of the abrasive particle is something which is very bigger in nature, then due to this what is happening, the material removal rate will not happen. मटेरियल रिमूवल रेट और घटने लग जाएगा. क्यों घटने लग जाएगा? क्योंकि प्रॉपरली ये एनर्जी वर्कपीस में इंपार्ट ही नहीं हो पाएगा. इतना बड़ा है ना ये, इतना बड़ा एब्रेसिव के कारण प्रॉपर जो आपका जो एनर्जी ये कैरी करेगा वो यहाँ पर वर्कपीस में दे ही नहीं पाएगा. एंड फॉर दैट रीजन यहाँ पर मटेरियल रिमूवल रेट डिक्रीज करने लगेगा. Okay, so when you are increasing the size of the abrasive, so up to at the maximum, at the optimal size, you will get the highest material removal rate, and after that your material removal rate will go down. So basically you will get a curve like this. Okay, understood or not? So this is the curve that you will be getting in case of MRR versus size of the abrasive. Let's talk about, sir, even if we vary the size of the abrasive, mass flow rate remains the same now. So how it affects? If the abrasive size is small, it should machine more since high of surface area. Please explain. Is no Mihir, no. अगर आप एब्रेसिव, ओके, यस, आई एम एक्सप्लेनिंग वंस अगेन. देखिए, अगर सपोज दिस इज द प्लेस ऑफ द वर्कपीस. नाउ ट्राई टू थिंक अबाउट इट. अगर आपने इतना बड़ा साइज का, सपोज दैट इफ योर साइज ऑफ द एब्रेसिव इज लाइक दैट, दिस इज द साइज ऑफ द एब्रेसिव. Now think about it that this is the size of the abrasives that you are giving. Now due to this bigger sizes, what will happen? You are giving 1, 2, 3, 4. So you are giving, suppose that you are giving the 4 abrasive particle in this case, and out of this 4, due to its bigger size, only 1 abrasive is in the interaction with the workpiece, and hence due to this interaction there would be a material removal rate. Now what is happening? You are giving these things also, you are giving these 2, 3 and 4 also, but 2, 3 and 4 will not get interacted with the workpiece, and whatever the kinetic energy that these abrasive will pose, these abrasive will loses its kinetic energy on this one abrasive, that is abrasive number 1. तो बात तो वही हो गई ना कि आपने 6, 7, 10 एब्रेसिव पार्टिकल तो भेजा, लेकिन इफेक्टिव इफेक्टिव में आपका सिर्फ एक ही एब्रेसिव वहां पर इंटरेक्ट किया। क्यों इंटरेक्ट कर रहा है? क्योंकि साइजेस बहुत ज्यादा हो जा रहे हैं, वहां पर एक्यूमुलेशंस बहुत ज्यादा हो जा रहे हैं, जगह बहुत कम है, मशीनिंग करने वाला जगह वहां पर बहुत कम है, तो एब्रेसिव फिट कैसे बैठेगा? एब्रेसिव फिट नहीं बैठेगा तो प्रॉब्लम क्या आएगा? प्रॉब्लम यह होगा कि कुछ एक सर्टेन लिमिट तक, मतलब अगर अगर कुछ इस तरह का लिमिट था, इफ सपोज दिस इज द वर्क पीस, कुछ सर्टेन लिमिट तक, मतलब आइडियली अगर आपका साइज कुछ ऐसा हो, ideally if your size is something like that, then what you can understand that here the machining will be more. But if the size will be very more, then the machining will be very less, material removal rate will be very less. So I hope this is clear to you. Sir, I didn't understand how very small abrasive MRR is low since more particles will come in contact. Mihir, for this point of time, I will suggest you to re-watch this video, okay? Because I have explained this concept 3 times, okay? 3 times I have explained this concept. So I would recommend you to watch this again concept so that that is very much clear to you. ठीक है? अरे ये तो छोटा सा चीज है, जितना ज्यादा बड़ा पार्टिकल्स होगा वो जगह ले लेगा। ये देखिए यहाँ पर इट इज टेकिंग द इंटायर प्लेस, इट इज टेकिंग द इंटायर प्लेस। और अगर ये पूरा जगह ले लिया तो ये दूसरा जो एब्रेसिव पार्टिकल्स है ये कहाँ गया? ये तो वर्कपीस में आ ही नहीं रहा है ना, फिट नहीं बैठ रहा है, बिकॉज यू हैव अ वेरी लिमिटेड अमाउंट ऑफ प्लेस इन विच यू वांट टू डू मशीनिंग। Understood or not? Understood or not? Understood or not? चलिए कोई बात नहीं। Now see here, if you want to, if you will increase the frequency, if you would increase the frequency of the vibrations, and then if you want to plot the material removal rate, so what will be the material removal rate when you are increasing the frequency? Can you tell me that when you are increasing the frequency, है ना, जब आप फ्रीक्वेंसी जो है आप इंक्रीज कर रहे हैं, when you are increasing the ultrasonic frequency, then MRR should be what should be the nature? Can you tell me? Can you tell me what should be the MRR, variation of MRR? You tell me and then I will try to explain the everything. Okay, आप ही बताएं मुझे. Tell me, if you are increasing the frequency, then what would be the variation on the MRR? What kind of variations that you will be getting? Frequency ज़्यादा means oscillation ज़्यादा, so MRR ज़्यादा होना चाहिए. Very good. So basically what is happening? So ideally you should get this kind of variation. Ideally you should get this kind of linear variation, and hence this is the ideal thing. But in actual case, due to loss of some kind of energy, this is what you are getting. So basically the graph that you are getting is this. So in this graph also you can understand that when frequency is more, then MRR is more. When frequency is more, MRR is more. Isn't it? Okay. So this is the graph. Fine. So this is for the theoretical. You do not have to worry about it. This is the actually theoretical graph. And this is you will get for the actual practice. Now if you are plotting the MRR, just a minute. If you are plotting the MRR versus the amplitude, then what should happen? Tell me. if you are increasing the amplitude, then what should be the variation in the MRR? Can you tell me? कैन यू टेल मी, अगर आपका एम्पलीट्यूड, सपोज करें कि एम्पलीट्यूड आपका कम है तो एमआरआर क्या होगा, एम्पलीट्यूड अगर ज्यादा होगा तो एमआरआर क्या होगा? कैन यू टेल मी व्हाट शुड बी द वेरिएशन, व्हाट शुड बी द वेरिएशंस? एंड डेफिनेटली आशीष एंड शुभम राज इज गिवन द करेक्ट आंसर्स. एमआरआर कम होगा सर. ओके ओके ओके, वाई कम होगा? एम्पलीट्यूड तो आपका ज्यादा बढ़ रहा है ना. सी हियर, अगर एम्पलीट्यूड ज्यादा हो रहा है मतलब वाइब्रेशन बहुत ज्यादा होगा, है ना. लॉन्गिट्यूडनल जो यहां पर मूवमेंट हो रहा है, सी द मूवमेंट दैट आई हैव एक्सप्लेन्ड हियर इन दिस केस. See, in this case, the longitudinal movement will be more. Longitudinal movement will be more. So basically, vibration, whatever the mechanical vibrations that is being produced in this transducer, that will be concentrated in a very large amount at that part. Okay. So for that reason, what is happening? You will be getting something like that. Something like that. Okay, so if you are increasing the amplitude, MRR will be more. Now suppose that this is the amplitude, suppose A1. Fine, A1 is the amplitude, and you want to increase this amplitude more. That is, if you are using this kind of something like this, that is, this is amplitude is A2. So basically you can say that A1 would be less than A2. A1 would be less than A2. See here. Now in this case, what you can understand, let's see, just a minute. What you can understand, that suppose that this is the A1. Clear? This is the A1. Just let me draw the figure and then I would explain it. Now this is again the A1. But in this case, this is F1, this is F2, and this is F3. So basically what you are doing in this case, frequency is more. So F1 is less than F2 is less than F3. So basically what you are doing, you are increasing the frequency. In this case, you are increasing the frequency. Now when you are increasing the frequency in this case, then the variation of amplitude with the MRR will be something like that. Yes, Mihir, and definitely you can see whatever you have explained in your doubt, that is the same thing that I have replicated in my figure, isn't it? Can't you correlate this? Can't you correlate with your doubts, whatever your doubts are there? Can't you correlate your doubts with whatever the graph that I have explained here, isn't it? So I hope you are able to correlate it. Okay, now see here, if I am talking about the feed force, okay, so if I am talking about the feed force, so basically I should write it here. Okay, so just a minute. So this is the graph in which you are talking about size of abrasives. Okay, in this graph you have talked about the frequency, and in this graph you have talked about the amplitude. And the next graph that you are going to talk about, in this we are going to talk about, is the static loading. And basically in this static loading, what I want to say, that is the feed force. सो सी हियर, अभी आप देखें यहां पर ये फीड फोर्स का मतलब क्या हो गया. ट्राई टू अंडरस्टैंड विद एन increase in feed force the MRR tends to increase. है ना, ऑब्वियस सी बात है. अगर अगर आप फीड फोर्स है ना, फीड फोर्स नीचे जो फीड फोर्स लगा रहे हैं, अगर फीड फोर्स ज्यादा होगा तो एमआरआर ज्यादा होगा, है ना. आर यू अंडरस्टैंडिंग दिस और नॉट? सो what is happening that if you are plotting this, so suppose that if you are plotting this in this graph like this is the graph in which you are plotting the MRR, material removal rate, and at this you are plotting the feed force. So basically what will happen, that when you are increasing, the feed force, when you are increasing the feed force, then MRR should increase. So basically you will be getting something like this graph would be there. Now understand, अब एक चीज समझें कि अगर this is your workpiece, and if you have given the more feed force, suppose that this is the feed force that you have given till now, and after that you are giving the more feed force like that, then what will be happening? So more feed force would be happening. So to try to understand that at this place earlier the abrasives are present, isn't it? At this place abrasives are present. Now what you are doing, you are increasing the feed force. So due to this increment in the feed force, this tool will come in the contact with this abrasive particles, and hence what will happening, crushing will take place. Okay, so what is happening basically, you would understand that however in practical or in practice, thanks for the lecture, I will watch later. Okay, no problem, definitely. However in practice it tends to decrease beyond a certain critical value of the force as the grains or abrasives are crushed. So I hope this reason is clear to you, that due to this crushing, what is happening, your problem will be happening that when at the certain point, at the maximum certain point, more feed force you will be getting, your material removal rate will be low. Clear? So basically this is the graph that you will be getting. Okay, this is the graph that you will be getting. Now suppose that this is the MRR versus feed force. Now till now, if you have any kind of doubt, you can ask with me. And the next last graph that I want to tell you, suppose that if you want to plot the graph between the abrasive concentration, so what will happen at the abrasive concentration? अगर आपका abrasive का concentration, if the concentration of abrasive, let me write it here, abrasive concentration, that is in percentage. Suppose if you're talking about the abrasive concentration and you are plotting the MRR, so more will be the abrasive concentration, मतलब abrasive particles ज्यादा होगा तो material removal rate बहुत ज्यादा होगा, है ना, material removal rate बहुत ज्यादा होगा. सर प्लीज लास्ट वाला ग्राफ डिक्रीज कैसे हो रहा है, देन एमआरआर वर्सेस स्पीड फोर्स। ओके, डिक्रीज कैसे हो रहा है? देखिए, अगर अगर फीड फोर्स बहुत ज्यादा हो जाए, मतलब कि सपोज करें दैट earlier the tool is at this place, okay, now you have given the more feed force, so the tool is taking this place. This is the state 1 and this is the state 2. So at the state 2, this is the tool taking the place, and now at this point, at the state 2, what is happening? The abrasive particles are crushed out. Okay, so abrasive particles will be crushed out. So what is happening? Due to crushing of the abrasive particles, the problem that you will be getting is that material removal rate will decrease. Why getting it will get decrease? Because जो भी यहाँ पर आपका एब्रेसिव पार्टिकल होगा ना, वो तो आप क्रश कर ही रहे हैं, और बहुत ज्यादा अगर फीड फोर्स होगा तो आप जो सप्लाई कर रहे हैं ना एब्रेसिव पार्टिकल्स, उसका सप्लाई का प्लेस मतलब जगह बंद हो जाएगा, मतलब बहुत कम फिर आपका एब्रेसिव यहाँ पर नेट आएगा, और जो भी यहाँ पर एब्रेसिव आएगा ना, उसको ये टूल जो है वो क्रश करते जाएगा। तो क्रश करने के कारण जो इफेक्टिव एमआरआर होना चाहिए वो नहीं होगा, और हेंस what is the reason? That is the reason that at a certain place, that is at a certain value of the feed force, you will be getting the optimal maximum MRR, and after that your MRR would be reducing. ठीक है? Now in this case, MRR versus abrasive concentration, suppose that what is happening? So if you are increasing the abrasive concentration, more will be the abrasive concentration. So more will be the abrasive concentration, more will be the MRR, isn't it? More will be the MRR, है ना? MRR बहुत ज्यादा होगा। लेकिन एक चीज आप सोचिए, अगर यहाँ पर suppose this is the tool and this is the workpiece. Now if abrasive concentration is more, that simply means that the abrasive is filled out, this whole place is filled out with the abrasive, this whole place is filled out with the abrasive, isn't it? Now think about it, एक certain value मतलब एक certain concentration के बाद, एक certain value of concentration के बाद आप उसके ऊपर if you will be adding more abrasive particles, तो भी क्या होगा ना, आपका MRR ज्यादा नहीं आएगा, क्योंकि MRR has reached to its saturated value, मतलब एक समय के बाद इतना ज्यादा वो एरिया पॉपुलेटेड हो जाएगा ना, this whole place is populated by entire abrasive grain sizes, and due to this what is happening, addition of more abrasive particles will do nothing. Why? क्योंकि एक खास वैल्यू पर जाकर के वो सैचुरेट कर गया एमआरआर का वैल्यू. सो आफ्टर दैट व्हाट यू विल बी गेटिंग द ग्राफ लाइक दिस, दैट इज द ग्राफ विल बी सैचुरेटेड. ठीक है, मतलब कि कुछ इस तरह का आ जाएगा. ठीक है, लाइक दिस. So this is the graph that you will be getting for the abrasive concentration versus the. Any doubt? Now suppose that this is for a silicon carbide. Now if you are getting if you want to find the graph for the boron carbide, then what will be the variation? So for the boron carbide, little bit more MRR would be getting because of the more hardness, of the material. So B4C would be the boron carbide. Clear? So I hope this whole everything is clear to you. Hello Birendra ji. I would recommend you to watch the videos from the starting point. Okay, अगर आप इस वीडियो को फिर से रिवाइंड करके स्टार्ट करके देखेंगे ना, तो आई एम श्योर दैट यू विल अंडरस्टैंड ईच एंड एवरीथिंग, बिकॉज दिस एवरीथिंग इज एक्सप्लेन्ड बाय मी इन अ वेरी बेसिक टर्म्स, है ना. बहुत ही बेसिक चीज में मैंने समझाया है आपको बिल्कुल समझ में आ जाएगा. ठीक है, एक बार आप रिवाइंड करके देख लीजिए. तो टिल नाउ ईच एंड एवरीथिंग इज क्लियर टू यू? नो डाउट. Shall I proceed to the next topic? Tell me, shall I proceed to the next topic or not? यहां पर जो है ना, ये देखिए, ये जो टूल हमने यूज किया है, लेट मी राइट इट हियर। ये जो टूल हमने यूज किया है ना, टूल मैं आपको बोला था ना, आई हैव टोल्ड यू दैट टूल इज मेड ऑफ द, somewhere I have told that tool is made of the ductile materials, right? So basically it is made of either of brass or copper, ठीक है। इन जनरल केसेस, ठीक है। तो यही तो खासियत हो गया ना नॉन ट्रेडिशनल मशीनिंग का, यही सबसे बड़ा खासियत है कि देखिए इतना सॉफ्ट मटेरियल से भी आप कितना हार्ड मटेरियल्स को आप मशीन कर दे रहे हैं, है ना। कितना हार्ड मटेरियल्स है, सपोज द हार्ड मेटल्स आर लाइक दिस, सो these are the hard metals like carbides, glass, ceramics. So by using, this is the benefit that we are getting by machining from the non traditional machining process, which is, in other words, it is also known as conventional non conventional machining process, ठीक है। चलिए, तो नेक्स्ट प्रोसेस जो हम बात करते हैं, दैट इज नोन एज, दैट इज केमिकल मशीनिंग प्रोसेस, ठीक है। केमिकल मशीनिंग प्रोसेस। सर क्लास का टाइम क्या है? वीरेंद्र जी, द टाइमिंग ऑफ माय क्लास इज 10 PM। 10 बजे रात को मैं आ जाता हूं ऑनलाइन और मैन्युफैक्चरिंग की क्लास को लेता हूं, ठीक है। Chemical machining process. So what is the chemical machining process? Now try to understand. Now try to understand. Before that, just a minute. So are you, so can you see these features, these complicated features, see here, very complicated features are there, isn't it? काफी ज्यादा कॉम्प्लिकेटेड फीचर्स बनाया गया है यहाँ पर, है ना। तो क्या होता है ना, अगर इस तरह का बहुत ही ज्यादा कॉम्प्लिकेटेड फीचर्स बनाना है, जिसमें कि सपोज करें कि for some part you do not want to get machined, and at the some other parts you want your workpiece to get machined, है ना। तो कुछ पार्ट मशीनिंग हुआ है, कुछ पार्ट मशीनिंग नहीं हुआ है। तो इस तरह का बाइफर्केशंस अगर आप करके एक बहुत अच्छा प्रोडक्ट with a very high accuracy if you want to make, so you will perform a process that is known as chemical machining process. Now chemical machining process is also known as केमिकल ईचिंग प्रोसेस। वाई ईचिंग प्रोसेस? मतलब ईचिंग मतलब क्या? ईचिंग मतलब आप समझते होंगे, ईचिंग मतलब खुजलाना। सो दैट इज द सेम थिंग दैट इज हैपनिंग इन दिस केस ऑल्सो। यू आर एक्चुअली etching the surface of the workpiece, and by this material removal rate is taking place. Material is removed from the workpiece and hence this is known as chemical etching process, ठीक है। चलिए समझते हैं इसके बारे में, chemical etching process या फिर chemical machining process कहते किसको हैं। So basically in this what is happening, basically this method involve the controlled etching of the workpiece materials in contact with the chemical solutions. Okay, so how these things are happening, try to understand. Suppose that you have, let me write it here. Suppose that you have a workpiece like this, okay, and you want to make a product something like this. You want to make something like this as your product. Okay, so you want to make this as your product. Okay, so basically this is your cross-sectional view. So if you would see the view, so you will be getting something like this. Okay, you will be getting something like this. So don't worry about these views, ठीक है। कुछ इस तरह का आपको चीज मिलेगा, ठीक है। जिस तरह का व्यूज आपको मिलेगा। So if you want to make these kind of complicated thing, so what you will do? So I will be talking about the cross sectional view. Okay, so don't worry about the three-dimensional view. So how we can make it? So basically you will put this workpiece in the chemical solution. So there is a chemical solution. Suppose that this entire container is filled with the chemical. Now what is the chemical? So I will discuss about what kind of chemicals you can use here. So basically what you will do, you will hang your workpiece, like this. Okay, you will hang your workpiece like this. This is your workpiece. Now what you will do, first thing that you will be performing is that cleaning. First step is cleaning. So basically if you want to make this kind of final product, so first of all you have to clean this workpiece so that any dust particles or any unwanted particles are there, that will be removed properly. After cleaning, what you will do, you will mask this, right? So what is the meaning of mask here? Basically you will cover this entire part, with the help of the mask. Now what is the meaning of mask? मास्क क्या होता है? अभी आप समझ लें कि सपोज दैट कि आप मास्क अगर चेहरे में पहनते हैं, क्यों पहनते हैं? क्योंकि जितना पार्ट आपका मास्क, चेहरा का जितना पार्ट आपका मास्क से ढका होता है, those part is not visible, isn't it? And the rest of the part is visible. So that is the why you want to cover your face with the mask, है ना? So the similar thing is happening in this case. Basically what is happening? So मैं टॉप व्यू बना रहा हूँ. Try to understand what is the thing that is I am telling you. Suppose this is the top view. So you have covered this entire place with the mask. You have covered your entire place with the mask. So this is the masking that you have done. Okay, this is the whole entire workpiece is covered with the mask, है ना? ये एक मास्क होता है जिसको हम बोलते हैं, जिस प्रोसेस को बोलते हैं मास्केंट, है ना? मैं बता रहा हूँ, डोंट वरी अबाउट इट. The entire place is masked. Now what you will do here? You will rest. After that you will develop these shape features, because you want to make these kind of shape features on this mask, isn't it? तो आप इसके बाद क्या करेंगे ना, you will develop the shape feature like this, that you want your machining like this. So you will develop the shape feature like this. ठीक है, इस तरह का आपने बना लिया. सपोज करें इस तरह का आपने शेप फीचर बना लिया. So when you are developing these kind of shape feature, then what is happening, my dear friend? What is happening when you have developed the shape feature? So this much part from these parts, mask is removed, and these parts mask is present. Now think about it, that at certain part, this part, mask is not present. At this certain part, mask is not present. So when mask will not present, what will happen? Try to think about it. This is the workpiece. And what I am telling to you, that this much part is covered with the mask. Again, this much part is covered with the mask, and again this much part is covered with the mask. So this is covered with the mask. This entire part is covered with the mask. Now see here, this entire workpiece is dipped down in the chemical, isn't it? So this is your maskant. Let me write it here. This is known as maskant. ठीक है, अभी ये क्या है? ये तो केमिकल के अंदर डूबा हुआ है. अभी अगर केमिकल के अंदर ये डूबा हुआ है, think about it, what will happen? The chemical will go down here. So chemical will react at this place. react at this place. Okay, so chemical will react at these places, and hence what will happen at these places, material will get removed, material will get removed, material will get removed. But what is happening, if you are talking about these places, at these places, due to the presence of the mask, what is happening, no machining takes place, no material removal, takes place. So by using these kind of maskants, you are actually producing these kind of shape features, and this is what is called as the chemical machining process. So basically the first process that you have done is known as cleaning. Second process that you are doing is known as masking. Third process that you have done, that is known as etching. मतलब ये, this is the process that is known as etching. And the fourth process would be demasking. So what is the meaning of demasking? After the machining is done, when the machining is done, just remove these masks. So when you are removing these marks, you will find that up to this part no machining is there, this part machining is done, again up to this part no machining is there, again at this part machining is done, and hence after removing the marks you will be getting the product. So basically this is the process that is known as demasking. So this thing is clear to you or not? So basically these chemical machining process are used to make these kind of features or circuit boards or plates for printing. ठीक है, कुछ इस तरह के एप्लीकेशंस में हम यूज करते हैं केमिकल मशीनिंग प्रोसेस. Chemical machining process. Now you may be wondering, sir, you haven't told anything about the chemicals. Yes, I am telling you about the chemicals. So basically in this what is happening, a stirrer is connected. So basically a stirrer is connected like this, and this stirrer is rotating, and hence the chemical is mixed properly here. Okay, so chemical is mixed properly here. Let me draw very clearly. This is the stirrer which is rotating like this, and the chemical is mixed properly, and this chemical is heated or cooled based upon the necessity by these coils. ठीक है, और suppose that in this case if your material is aluminum, then the chemical that you will be using is sodium hydroxide. And if the material is steel, then the chemical that you will be using is nitric acid or HCl. So these are the chemicals that is used. So this is all about the chemical machining process. Okay, this is all about the chemical machining process. Any doubt till now? कोई doubt? Any doubt till now? Just let me know. If you have any kind of doubt, just let me know. I am waiting for your reply. ठीक है, एक और चीज जो होता है, जस्ट 1 मिनट लगेंगे आपका, 1 मिनट में मैं बोलना चाहता हूँ. देयर इज अ प्रोसेस दैट इज नोन एज फोटोकेमिकल ईचिंग. ठीक है, एक और प्रोसेस कहते हैं जिसको नोन एज फोटो photochemical etching. So what is happening in this photochemical etching? Basically, in that part, what you are doing, you are covering your workpiece. You are covering your workpiece with help of a photosensitive mask. So there is a mask. So this mask is covered with. This mask is basically the photosensitive mask. Okay, so this is mask is known as photosensitive mask. And what is happening here, basically just a minute. So basically this is a photosensitive material. ये जो होता है ना, ये फोटो सेंसिटिव मटेरियल होता है. ऊपर में वर्कपीस के ऊपर में आपका फोटो सेंसिटिव मटेरियल्स होता है, और इसके ऊपर में आप क्या करते हैं, एक आप, let me take one another color. So what you are taking, you are actually taking a mask. So this is the mask, fine. And on this, suppose this much part is totally masked, which is not exposed. This much part is also not exposed, and this much part is also not exposed. So what is happening in this case? Light radiation is coming. So light radiation, when the light radiation will be coming, so at this part, what is happening, etching will be taking place. At this part again, the etching will be taking place, and this much part will be removed. And by doing this, you are getting the photochemical etching, है ना. तो फिर इससे भी आपका सेम ही प्रोडक्ट बनता है, but the thing is that the process is slightly different. In this, photons are used for the machining purposes. So this is what is all about for the today's session. If you have any kind of doubt, you can ask with me. And meanwhile, definitely, if you want to enroll in a plus subscription, then use my code SIRVK, SIRVK, to get a 10% off, as well as you will get my personal mentorship. Okay. Now, one more thing I should tell you that you may be wondering. एक और चीज जो हो सकता है कि देखिए, being an educator, I am thinking like you, ठीक है. You may be wondering, sir, mask में ऐसा होता क्या है? Mask होता क्या है ऐसा जिसके कारण उसमें होता नहीं है, उसमें reactions नहीं होता? So basically what is happening, the mask is actually made of inert materials, and hence no reactions took place, or no reactions takes place due to chemicals. Okay, so this is the most important thing that I should tell you. चलिए, कोई doubt, any doubt in this entire session? Just ask with me. I'm waiting for your reply. Any doubt? Okay, so everything is clear to you. So definitely tomorrow also you will be seeing a new process, that is ECM. Will be discussed tomorrow, and again with the new topic, with the new things. Try to absorb the materials, try to understand the concepts, and definitely if you have any kind of doubt, you can reach out to me. I would try my level best to help you throughout. Till then, if you have any doubt, just ask with me. Otherwise, I am going to end the session. Okay. And if you have enjoyed this video, so definitely do not forget to like this. Video, as well as share this video in your friend circles. And remember to use my code SIRVK to get the 10% off. So thank you so much. I'm ending the session. I assume that you have your doubts are cleared and you have understood everything. Yes, tomorrow the recorded lecture would be there. So thank you so much for your active participation. I'm making this session to be very much interactive. Thank you so much.